Hello students, welcome to the second unit of the digital signal processing. So in the second unit we are going to study what is Z transform, why exactly it is needed. So let's see this particular equation. So in this equation, if you just concentrate, you will find that in the equation Z equal to X plus IY. Instead of I, sometimes you may use it as a letter J. So this particular equation represents, it is nothing but the complex number. So Z equal to X plus IY. From this particular thing, X is nothing but the real part of the equation and Y is nothing but the imaginary part. So when we discuss the Z transform specifically, we are interested in the real part as well as the imaginary part, because the Z transform, it is nothing but simply the combination of real and imaginary parts. So that is why when we plot any Z transform, we are interested in plotting it with respect to the real and imaginary parts. So let's discuss in detail what exactly it's need, why to go for the Z transform. So this is what some of the reasons why we need to go for the Z transform. In the first statement itself, we can able to analyze the concept called as a ROC. So when we say it is ROC, region of convergence, so ROC actually decides the stability of any system. So that is why for analyzing any system, specifically the LTI system, it is required to go for the Z transform. Second thing, in the second thing, Fourier transform does not converge on all sequence. So this is what one of the reason, if it is not getting converging on all sequence, that is why we need to go for the Z transform. We will see what exactly this convergence means while studying the ROC concept, that is region of convergence, in detail. Third reason why to go for the Z transform, it is the Z transform is nothing but the tool in describing and analyzing the digital system. So for any digital system to decide whether it is stable or causal, we need to go for the Z transform. Fourth reason, it offers the techniques for digital filter design. So every digital filter design is based on its coefficient. So when we calculate the coefficient of the filter, we are able to decide whether the filter is stable or not stable. So that is why we will require again the Z transform. Next reason, it offers frequency analysis of the digital system. So obviously when we go for the Z transform, we are converting the signal from discrete domain or the digital time domain into the frequency domain. So that is why it offers frequency analysis of the digital signal. Second last reason is a signal can be characterized with its Z transform. So for any signal to be causal or non-causal, we can easily decide it based on its Z transform, or rather on its ROC also. Lastly, for finding the transfer function, specifically again in case of the LTI system, we can go for the Z transform. So these are some of the reasons why we need to go for the Z transform. For this last point, if you are able to recall some of the points which you studied in the control system, like transfer function means it is nothing but the output by input application based on the Laplace transform, Laplace of output by Laplace of input. So in the same way, we can go for finding the transfer function, but based on the Z transform concept. So that can be easily done with the help of some of the applications of the Z transform properties. So it will be easily done. So this is how the transfer function can be easily obtained for the LTI system by using the Z transform. So thank you everyone. Thank you very much. In the next lecture, we are going to detailing about the other concepts of the Z transform. So thank you everyone. Thank you very much.